So the last time we got together, we talked about the standard deviation and the variance. And one of the things I wrote down was formulas for both standard deviation and variance. Now the reality is I'm not going to make you memorize those formulas. That's really not the purpose. What I do care about, though, is that you know the notation. And so the standard deviation of a sample is this, and the standard deviation of a population is the Greek letter. And then the variance of a sample is this, and the variance of a population is this. Notice it's the squares of the standard deviation. That's important to remember because in our class we're always going to use the calculators, as I showed you in the last video, to find the standard deviation and variance. So let's move on to talking about what does the standard deviation give us in a set of data? How's it break it apart? So one of the key things in understanding a standard deviation is called the empirical rule. And it gives us a broad definition of how the standard deviation breaks up a set of data in terms of the counts, how many of the data fit within a group. And so what you talk about is within one standard deviation, two standard deviations, or three standard deviations of the mean. And what I mean by that is either 1 times whatever the standard deviation is, plus or minus from the mean, or the mean plus or minus 2 times the standard deviation, or the mean plus or minus 3 times the size of the standard deviation. And when you do that, there are 68% of the data within one standard deviation, 95% of the data within 2 standard deviations, and 99.7% of the data within 3 standard deviations. What I'd like to do is maybe draw you a picture to give you a little better idea of what this means. So what I've done is I've drawn a picture to illustrate this empirical rule, and here's the whole picture so you can see it. And what I want to show you is on this picture what I'm basically talking about when I talk about within one standard deviation. So standard deviation is going to be a number that in some sense measures the average distance element of data is away from the mean. And so once I find that, this distance then, right here, this distance right here is going to be equal to 1 standard deviation. Okay? 1 standard deviation. Now, this on the number line right here, this point on the number line, if I take the mean plus that distance, 1 standard deviation, that's what I mean by the 1 standard deviation above the mean. With the mean in the middle, then this point on the number line will be the mean minus 1 standard deviation. So this whole space right here, that whole space on the number line is within 1 standard deviation of the mean. And in the same way, we could talk about the mean minus 2 standard deviations, or the mean plus 2 standard deviations. And if you wish, we could go even further, the mean minus 3 standard deviations, or the mean plus 3 standard deviations. And that would be how you would label it on a diagram. And then if you take the 2 blue marks, say here and here, that's within 2 standard deviations. And the 2 white ones, here and here, are within 3 standard deviations. So and what this will typically look like, what you'll see is a picture that looks something like this. All right, and you will see it marked off like this, which is a space. So within one standard deviation is 68% of the data. Now I've assumed my data is symmetric here, but this holds generally true even for data that's not symmetric. Approximately 68-70% will be within one standard deviation. So now if I go to the next level, what if I'm within 2 standard deviations? So now I'm looking at all the data between the 2 green lines. Well, all that data then between those is 95% of all data is between those 2 green lines. Okay? And then finally, if you go to the white data, between the 2 white lines is approximately 99.7% of all data. And so these kind of overlap each other, so you have to visually be able to understand that. Now what happens is you can take pieces of these data and work it out. Like, well, what about between 1 standard deviation and 2 standard deviations? Well, if you notice, up to here is 68 in the middle. So if I were to cut that in half, that'd be 34. And if I cut the 95 in half, that's 47 and a half. So 47 and a half minus 34 gives you how much is in between the green and the yellow, or 13 and a half. So you can start to do little math problems figuring out how much of the data is between numbers by dealing with these percentages. Understanding that if you're doing this on a symmetric distribution, it kind of cuts things in half, and that'll help you cut these numbers in half and so forth. So that's the basics of the empirical rule. Let's try and do a problem on the next page. So what you see here is a random sample of tire rim prices at a local tire store. Actually, that's where I'm at now, getting some tires on my car. So this is actual data, and this is what the rim prices are each. Of course, you'd have to buy 4 rims at these prices to put them on a car or whatever if you wanted to fancy up your car a bit. So these tire rim prices are going to be our data that we're going to use to kind of set up what we're looking at. So I'm going to do some calculations here so you can see it, and we'll go from there. So I found the mean and the standard deviation of this set of data, which you can do on a graphics calculator quite easily. So I'd encourage you to do that to check this out. If you're at home, you could even do these on a cheapy calculator. If it's scientific, it'll figure these out. You just have to know how to do it. If you have a graphics calculator at home, you can do this. So what I'm going to show you is I'm going to put the mean here. This is mean, and it's 170. And now I want to do the mean plus a standard deviation. All right. So as I was saying before I had to pay my bill for my tires, is the mean plus 1 standard deviation is here, and that we now actually have numbers, so that would be 170 plus 49, which actually works out to 219. And we could do the mean minus 1 standard deviation, be approximately 121. All right. and then the mean plus 2 standard deviations. That would be 268. The mean minus 2 standard deviations. That would be 72. And you could go to 3 if you wanted at this point. 3 standard deviations in each direction. So this is what it actually means with real data. Is once you know the mean and the standard deviation, you can kind of create this number line. Now, what this also means is that there is approximately, again, 68% of the data within 1 standard deviation of the mean. So between 121 and 219, and so if we go count those data points, that's 1, 2, 3 data points out of 5. So we have 60% of our actual data between those two numbers. So that's pretty close. Even with this small data set, we were actually pretty close. So if I go within 2 standard deviations, I should have 95% of the data within 2, and that would be from 72 to 268, and in our case, that would be 100% of our data, which is approximately close to 95%. So even if our data is not symmetric, this empirical rule seems to hold. If I went 3 standard deviations above and below, that's 99.7%. That would actually be really close as well. So my point then with this example was to show you that with real data, these percentages might not be exact, but they are very close to what will actually happen even with a real set of data. So one of the things you're going to be asked to do in your problems is to find the range, the variance, the standard deviation, the mean, and then interpret the results. When you go to interpret, you can just say that the range is the distance between the maximum and the minimum value. When you interpret the standard deviation, though, which is the one you want to interpret, that's what they're really asking for. What should you do? You just need to remember that a standard deviation is the typical amount a single piece of data deviates from the mean. All right? And what I mean by that is the more the data is spread out, the greater the standard deviation will be. The more tightly packed the data is, the smaller the standard deviation will be. So for instance, in our data is spread out from 110 to 240, that's the range. The mean is 170, kind of right in the middle of that. And we are, therefore, the standard deviation of 50 represents the amount that a typical entry would deviate from the mean, or in our case, a typical single rim price would deviate from the mean. Okay? Our data's somewhat spread out so that standard deviation is quite large. It's also large because our numbers are larger. The other thing to remember is the empirical rule really only applies to symmetric data. So when you're asked to use it, make sure you just remember that it applies to like bell-shaped symmetric data. Okay? Let's see if there's another problem type we want to talk about. I would mention that the empirical rule table in your textbook on page 88, page 88 is really important, and you should look at that. I've drawn similar things in this lesson, but you really want to pay attention to that as well, because it shows you finer divisions. What it does is it takes the symmetric distribution and it splits it up into standard deviation parts. So it takes the 68% and divides it in half into two 34% parts. The 95%, it subtracts the 68 and takes that 27% and divides it into two parts, 13.5%. And then the same thing is done with the 99.7. You subtract the 95 and you have 4.7 left, so each part here is 2.35%. That's really important to remember as you answer some questions. One question you might get is, well, if we use our tire frame data that I still have up here, what's the percentage of data between $170 and $268? So between those two. Well, what I know is, based on what I just said, this amount here, one standard deviation above, is 34%, and 268 is two standard deviations above. So I know that this portion here, between 1 and 2 standard deviations, is 13.5%. So if we add these two percentages together, we get 48.5%. So if I am asked what percentage of data is between these two numbers, and they're on the mean or 1 standard deviation above or below or 2 above or below, then you would find that percentage using the empirical rule. And in this case, the answer would be 47.5%, the 34 plus the 13.5. Okay, I think that's all. We'll answer any other questions in class tomorrow.